I'm audible. Hi, dear students. I'm audible. Hi, dear students. I'm audible. I'm audible, students. Okay. Hi, dear students. This is Nandini Miss from Goscore Learning Center. We are the fastest edX company in GCC. So, today we will discuss electromagnetic induction part 2. Already we discussed electromagnetic induction part 1. Today we will discuss part 2 of the electromagnetic induction. So today we will discuss some topics. EMF. Again we will revise the what is the EMF. Next, what is the method of producing induced EMF. Next one, Lenz law. What is Lenz law? Again, direction of induced current by the Lenz law. And one more thing, energy conservation by using the Lenz law. Finally, inductance, and the types of inductance are self-inductance and mutual inductance. So first of all, we will revise what is EMF. So whenever the change in flux occurred, then EMF will be induced according to the Faraday's law. This all those things we discussed in part 1. So whenever the change in flux occurred, then EMF will be induced. Whenever change in flux occurred, EMF will be induced. Here EMF is directly proportional to the flux. Flux will be changed, EMF will be induced. So, first of all, what is the flux? Flux is equal to, we know that BA cos theta. Flux is BA cos theta. Then E is proportional to the BA cos theta. So here EMF is depending upon the magnetic field, area and orientation of the coil. So EMF will be occurred by the change in magnetic flux. Flux will be changed, EMF will be induced. So E is equal to the rate of change of flux. E is equal to EMF is equal to the rate of change of flux. Flux is equal to BA cos theta. BA cos theta, and EMF is depending upon the BA cos theta. B is the magnetic field, A is the area, theta is the orientation of the coil. Orientation of the coil. So, methods of producing induced EMF. First of all, we know that EMF is depending upon the BA cos theta. EMF is depending upon the BA cos theta. It means magnetic field will be changed. EMF will be changed. Area will be changed. EMF will be changed. Theta will be changed. EMF also change. So EMF here depending upon the magnetic field, area and theta, orientation of the coil. So E is equal to d phi by dt. E is proportional to the change in flux and E is proportional to the BA cos theta. Phi is equal to BA cos theta. So EMF is depending upon the BA cos theta. B means magnetic field, A is the area of cross section and theta is the orientation. So by changing magnetic field, how EMF will be changing? So by changing magnetic field, how EMF will be inducing? So we know that according to the Faraday's law, magnetic field will be changed. Flux will be changed. Magnetic field will be changed. Flux will be changed. There is a change in magnetic flux. What will be induced? EMF will be induced. EMF will be induced. Magnetic field is changing. Flux is changing. There is a change in flux. According to the Faraday's law, change in flux is there. What is happening? EMF is induced. EMF is induced. Why? Flux is equal to BA cos theta. So here B is changing, flux is changing. So When there is a magnetic flux is changes, EMF will be induced in a coil. Magnetic field will be changed, flux will be changed, there is a change in flux is there, then EMF will be induced according to the Faraday's law. According to the Faraday's law. Next, by changing area. By changing area. So here we know that already phi is equal to BA cos theta. Here area will be changed. Area will be changed. Flux will be changed. There is a change in flux. What is happening? EMF will be induced. So here area is changing. Flux is changing. There is a change in flux. Then EMF will be induced in that coil. That is the by changing area. That is the by changing area. By changing area, here EMF is induced. Here this EMF induced we called as a motional EMF. By changing the area, we are getting EMF. That EMF we called as a motional EMF. What we call? Motional EMF. So, motional EMF. Here I am taking guys one metallic frame. Here I am taking metallic frame. What is EMF? Here we will conclude. So first of all I am taking PQRT metallic frame I am taking. One more thing, here I am taking magnet also. For magnet what are the poles? North pole and south pole. North pole and south pole. Here I am considering north pole is outside, south pole is inside of the board. Then we will indicate magnetic field lines inside the board. That's why here I am taking cross indication. So here magnetic field lines passing inside the board. That's why I am indicating cross. Outside the board we will indicate like this. Outside the board we will indicate like this. Inside the board we are indicating like this symbol. So I am taking magnetic field lines inside the board. That's why I am considering this symbol of field lines. Magnet is there, magnetic field lines is there. Magnetic field lines is there, magnetic flux is there. So this area is the magnetic field area. Then I am taking metallic frame. Then I am taking one metallic frame. I am taking one metallic frame. I am indicating this metallic frame as a P, Q, or T. I am indicating this metallic frame as a PQRT. Then I am taking one wire. Then I am taking one wire sliding to the metallic frame. Sliding to the metallic frame. Then I am taking one metallic wire. That metallic wire I am indicating as a XY. The metallic wire I am indicating as a XY. This XY metallic wire length L and breadth is X. So this metallic wire length is L. This is the distance. Okay. Then I am taking flux phi in this area. So I am considering in this position what is the flux. That flux I am indicating as a phi 1. In the first position I am taking flux as a phi 1. Generally what is the formula guys? B A cos theta. B A cos theta. Then here phi 1 is equal to B into, we know that area is equal to L into breadth, length into breadth. Here breadth is X, here breadth is X. Then area is equal to L into X cos theta, L into X cos theta. Here area and magnetic field at both are in parallel. What is the theta? Magnetic field and area both are in parallel. Both are in parallel. Theta is equal to 0 degrees. Both are in parallel. Theta is equal to 0 degrees. Then phi 1 is equal to B. Phi 1 is equal to B X L cos 0 degrees. Cos 0 degrees. Then phi 1 is equal to then phi 1 is equal to phi 1 is equal to, what is the formula? BXL cos 0 degrees. Cos 0 degrees. Cos 0 we know that phi is equal to BXL. So phi 1 is equal to BXL. I am indicating as a first equation. I am indicating as a first equation. Now I am changing the wire position. I am changing the wire position with the velocity. With the velocity V. Then the position of the wire now here. Now position of the wire here. I am indicating it is a X dash Y dash. I am indicating it is a X dash and Y dash. Then the length of the wire before up to here it is X. Then from the I am applying some velocity and then I am pulling the wire like this. Then the displacement is increasing. That displacement increasing we are indicated as a dx. We are indicating as a dx. Then total length is what? X plus dx. Now total length is, total breadth is x plus dx. Length is L. So what is the breadth now? X plus dx. The wire position is changing. That's why breadth also changing. X plus dx. X plus dx. Then what is the flux phi 2? What is the flux phi 2? Phi 2 is equal to BA cos theta. Phi 2 is equal to B into L into X. L into, length into breadth. Here length is L. What is the breadth? X plus dx. Change in position occurred. That's why the breadth will be changing. X plus dx. Breadth will be changed like a x plus dx. Cos theta here I am considering 0. Why? Magnetic field and area both are in parallel. That's why I am considering theta is a 0. Then phi 2 is equal to B L X plus B L D X. Cos 0 is 1. So what is the phi 1? BXL. Phi 2 is BLX plus BLDX. This is the second equation. This is the second equation. Then what is the change in flux? D phi is equal to phi 2 minus phi 1. Phi 2 minus phi 1. Then d phi is equal to, what is phi 2? BLX plus BL What is phi 1? BXL or BLX. Substitute that values. BLX plus BLDX minus BLX. See guys, here positive BLX, negative BLX cancel. Then we are getting d phi is equal to BL dx. BL dx. I'm taking now in LHS and RHS where I'm dividing with dt. Then d phi by dt is equal to BL dx by dt. So we know that E is equal to d phi by dt according to the Faraday's second law. So d phi by dt is equal to E. D phi by dt is equal to E. It is, I am considering here only magnitude, not a direction. That's why I am taking like this. EMF is equal to BL. We know that the rate of change of displacement is equal to velocity. Dx by dt is equal to velocity. Then what is the formula for motional EMF? What is the formula now? EMF is equal to BLV. Magnetic field into length into velocity. Magnetic field into length into velocity. This is the motional EMF by the changing of area. So E is equal to BLV. B is the magnetic field, L is the length of the wire, B is the velocity we are applying. So EMF is equal to BLV. This is the motional EMF by the changing area. Next one, by changing orientation. So I am taking now one coil and this coil having number of turns. For this coil having number of turns. From this number of turns, magnetic field is passing. For this number of turns, magnetic field is passing. I am indicating is B. And one more thing here, area. It is a area. Then here what is happening guys? Coil orientation will be changed. Coil orientation will be changed. Coil orientation will be changed. What is happening? We know that E is equal to d phi by dt. E is equal to d phi by dt. E is equal to d by dt. We know that phi is equal to BA cos theta. NBA cos theta. Here number of turns we are considering. NBA cos theta. NBA cos theta. Here number of turns is constant. Magnetic field is constant. Area will be constant. Here one more thing. Theta is equal to omega t. Here theta is the angular displacement. Theta is the angular displacement. Angular displacement. It means with how much angle it is going. So coil how much it is rotating, that is a theta. Angular displacement. Omega is the angular velocity. Angular velocity. T is the time period. T is the time period. Now E is equal to N is constant, B is constant, A is constant, then d by dt. I am substituting here theta is equal to omega t. Cos omega t. Cos omega t. So E is equal to N B A d by dt cos omega t. We know that differentiation here. E is equal to N B A. What is the differentiation of cos omega t? Minus omega sin omega t. What is the differentiation of cos omega t? Minus omega sin omega t. Then E is equal to minus N B A omega sin omega t. This is the EMF equation by changing the orientation. By changing the orientation. Then we are getting graph like this. Then we are getting graph like this. In one revolution, we are getting two values. In one revolution, we are getting two values that are negative and positive. Negative and positive we are getting in one revolution. This is we called as a alternating current. This is we called as a alternating current. We know that I is equal to E by R. Here R is the resistance. Here R is the resistance. E is the EMF. I is the current. This is the alternating current. So in one revolution we are getting the two values negative and positive. Next one. Lenz law. Lenz deduced the Lenz law. What is the Lenz law? So here EMF is producing by the change in flux. EMF is producing by the change in flux. And one more thing here, according to the Faraday's law, EMF is producing by the change in flux. That EMF is produced and it opposes the cause of producing it. It opposes the cause of producing it. From EMF will be producing by the change in flux, but that EMF will be oppose the cause of its production, from which EMF is producing change in flux. So this EMF is opposing the magnetic flux. That is, it will oppose the change in magnetic flux. EMF is opposing the magnetic flux. So that's why here we are considering minus. Here we are considering minus. That opposing we are indicating as a negative. That opposing we are indicating as a negative. Here N is the number of turns. We know that E is equal to d phi by dt. Here I am considering N is the number of turns. N is the number of turns. So what is the Lenz law, guys? According to this law, EMF will induced in such a way that it opposes the cause of its production. So in which cause will oppose the change in magnetic flux. EMF will be opposing the magnetic flux. That's why here we are considering minus. That opposing we are indicating as a negative. E is equal to minus N d phi by dt. Here N is the number of turns. Flux is a d phi by dt. Next, what is the direction of induced current? What is the direction of induced current? Here I am considering so many cases, guys. Here I am considering so many cases. 4 cases I am considering. First of all, what is anti-clockwise direction? What is clockwise direction? We'll explain. In a coil, coil having a north pole. Coil having a north pole, then the current direction is anti-clockwise direction. Then the current direction is anti-clockwise direction. Induced pole acts as a north pole. Induced pole acts as a north pole. Then it is producing the current direction is anti-clockwise. Then I am considering induced pole is south pole. Induced pole is south pole. Then the direction of current is clockwise direction. So induced pole is north pole, then the current direction is anti-clockwise direction. The induced pole is south pole, the current direction is clockwise direction. Now we will discuss the cases. What is the direction of current by the Lenz law? Case 1. Magnet, north pole, south pole. It is near to the coil. It means I am taking one magnet and I am taking one coil. Now the magnet is towards to the coil. The magnet is towards to the coil. What is the Lenz law, guys? EMF will oppose the cause of production. EMF will be oppose the cause of production. When magnet is near to the coil, when magnet is near to the coil, it means change in flux is happening there. When the change in flux is there, EMF will be induced. That EMF in the direction of opposed direction, in the opposed direction. Then what is happening? Here south pole is there. Oppose means what? Which pole here occurring? South pole. Now in this, which pole happening? South pole. So what is the direction of south pole? Clockwise direction. What is the direction? Clockwise direction. So when the magnet is near to the coil, here south pole is there. So here I am taking south pole. This south pole magnet is near to the coil. EMF will be opposed. Opposed means which pole here occurring? South pole. For the south pole, which direction we are getting? Current direction. We know that clockwise direction. Then I am taking, here magnet is towards the coil. Then I am taking case 2. Now, magnet is away from the coil. Magnet is away from the coil. So, when the away from the coil, here also change in flux is happening. So, when the magnet moving away from the coil, what is happening? Change in flux is happening. Then EMF will be induced. But according to the Lenz law, EMF will be opposed. Here, what is happening? It is away from the coil. That's why coil will be attract. Coil will be attract. Attract means which pole is here happening? North pole. Here south pole is there. That's why here north pole is inducing. North pole is inducing. What's the north pole direction? Anti-clockwise direction. What is the current direction? Anti-clockwise direction. Here towards to the coil, here south pole I am considering. Towards to the coil, here induced current direction is clockwise. Here away from the coil, here I am taking south pole. Which pole here inducing? North pole. What is the direction of north pole? Anti-clockwise direction. Now I am considering case. Now I am taking magnet, here north pole, here south. Now coil, then I am taking magnet towards to the coil. Towards to the coil, here north pole is there. Then here change in flux is happening. Then here EMF will be induced in a coil. But here what is the EMF is doing here according to the Lenz law? Opposing. Opposing means which pole here inducing? North pole. North pole and north pole are opposing. That's why here which pole is inducing? North pole is inducing. Then what is the direction of current? Anti-clockwise direction. Anti-clockwise direction. Then case 4. South pole, north pole. Then magnet is away from the coil. Magnet is away from the coil. Then what is happening? What is the EMF is doing here? Opposing. Opposing means here away from the coil. Then it will be attract. Then which pole is here happening? South pole is inducing. Then what is the direction of south pole? Induced current direction. Clockwise direction. So finally we conclude this one. So south pole is near to the coil. Here we are getting south pole inducing. Then the direction is clockwise. Here away from the coil, here we are getting north pole. Then direction is anti-clockwise. Here north pole is near to the coil. Then here we are getting in the coil is induced as a north pole. Then the direction is anti-clockwise. Here we are getting clockwise. So this is the direction of the induced current by the Lenz's law. By the Lenz's law. Next one, Lenz's law and energy conservation. Lenz's law and energy conservation. What is the energy conservation by the Lenz's law? Now I am taking one coil. This coil is connected to the galvanometer. This coil is connected to the galvanometer. Then I am taking one magnet. North pole, south pole. Here the magnet is 2 volts to the coil. I am taking 2 volts to the coil. Then what is happening? When 2 volts to the coil, magnetic flux is changing. When the magnetic flux will be occur, EMF will be induced. EMF will be induced. Change in flux is there. EMF will be induced. Then EMF will be inducing and the direction is opposing direction. Opposite direction. Here EMF is inducing. In which direction? Opposite direction. Opposite direction. Then this coil acts as a here north pole and here south pole. Here north pole is there. So here EMF is opposing means here which pole will be induced? North pole. Here south pole. Now I am taking away from the coil. Now I am taking away from the coil. Then what is happening here? Change in flux is there. Then EMF is inducing. EMF is opposing the magnetic flux. Then here away from the coil, then what will do here EMF? Attract. Attract. Attract means here north pole is there. Then here which pole will be induced? South pole. Here north pole. So 2 volts to the coil. Here north pole is inducing. Away from the coil, here south pole is inducing. Here south pole is inducing. Here for every time some work done is happening. 2 volts to the coil, EMF inducing and opposing. There also some work done is happening. Then away from the coil also some work done is happening. That work done we consider as a mechanical energy. That work done we are considering as a mechanical energy. That mechanical energy is converted into the electrical energy. That mechanical energy is converted into the electrical energy. Work done occurred by the moving magnet. So that work done we are considering as a mechanical energy. That mechanical energy is converted into the electrical energy. We know that energy is neither be created nor be destroyed. We are converting every time one form to another form. Here we are converting mechanical energy to electrical energy. This is the energy conservation. Every time we are getting mechanical energy, that mechanical energy is converted into the electrical energy. This is the Lenz's law of energy conservation. Next one, inductance. What is the inductance? So, it stores the magnetic energy. Inductance is the stores the magnetic energy. Here we know that according to the Oersted, current is inducing, current is passing through the coil, flux will be producing in that coil according to the Oersted. According to the Faraday's law, magnetic flux is there, current will be produced. It means flux is proportional to the current. Flux is proportional to the current. Current will be increased, flux will be increased. Current will be gradually increases, flux also gradually increases. Then I am considering here proportional relationship. We know that current will be increased, flux will be increased. Current will be increased, flux also increase. Current will be decreased, flux will be decreased. This is the proportional relationship. Then phi is equal to, I am taking a constant L. I am taking a constant L I. Here this L we called as a inductance. Here L is called as a inductance. This inductance stores the magnetic energy. Inductance stores the magnetic energy. Phi is equal to Li. Phi is equal to Li. Then L is equal to phi by I. L is equal to phi by I. From this equation, what is the definition of inductance, guys? What is the definition of inductance? The ratio of flux by current. The ratio of flux by current. What are the types of inductance? Two types of inductance is there. Self-inductance, mutual inductance. Two types of inductances is there. Self-inductance and mutual inductance. First we will discuss self-inductance. If the current passing through the coil changes, hence EMF is induced in the same coil, this phenomena is called as a self-induction. We are taking one coil, from that coil we are giving the battery, then from the battery we are getting current. According to the Oersted, what is happening? Current carrying coil produces a magnetic flux, but here current will be gradually increasing, flux is changing. By the changing flux, EMF will be induced. So that EMF is induced in the same coil. That's why it is called as a self-inductance. So current passing through the coil producing the magnetic flux. Here that flux is changing. That change in flux producing the EMF in the same coil. That's why it is called as a self-inductance. Now I am taking one coil. This coil having number of turns. Then this coil I am connected with battery. This coil I am connecting with the battery. Higher and lower. This is a battery. From the battery, current will be produced. Higher to lower position. Higher to lower. This is the current direction. This is the current direction. When the current passing through the coil, when the current is passing through the coil, what is happening according to the Oersted? Magnetic field will be produced. Magnetic field will be produced. When the current will be passing through the coil, magnetic field will be produced. Magnetic field is producing means flux is producing. Flux is producing. Here we are giving supply. Then the current I am giving 3 amperes. I am giving current is 3 amperes. These 3 amperes we are giving gradually. Current is increasing gradually, not at a time. 3 amperes. That current is increasing gradually. Current is increasing gradually means flux also increasing gradually. So current is increasing gradually means flux also increasing gradually. We know that I is proportional to phi, flux. Here current is increasing gradually means flux also increasing gradually. Here gradually increasing means what? Change in flux. Change in flux produces the EMF. Yes, change of magnetic flux produces the EMF. Then that EMF is producing in this coil only. EMF is producing in this coil only. That's why it is called as a self-inductance. In this coil only we are giving current. From in this coil only we are getting EMF. That type of inductance we called as a self-inductance. That type of EMF we called as a self-inductance. Then what are the equations? Current will be increased, flux will be increasing. Current is increasing, flux is increasing. Then I am taking constant phi is equal to L into I. Here L is the self-inductance. Here L is the self-inductance. Here L is the self-inductance. L is equal to phi by I. L is equal to phi by I. So, what is the definition? Ratio of flux by current. Then we know that E is equal to minus d phi by dt. Then minus d by dt. What is the phi value? Li. What is the phi value? Li. Then E is equal to L is constant di by dt. What is the EMF? EMF is equal in terms of self-inductance. EMF is equal to minus L di by dt. Then L is equal to minus E by di by dt. From this equation, L is equal to E by di by dt. L is equal to minus E by di by dt. Here I am considering di by dt. Di by dt is a 1 ampere per 1 second. 1 ampere per 1 second. Then 1 ampere per 1 second means it is 1. Then L is equal to minus E. L is equal to minus E. So, this is the self-inductance, guys. So, the current is passing through the coil. The coil is producing the magnetic flux. That magnetic flux is changing. When the change in magnetic flux will be occur, EMF will be induced in the same coil. That's why it is called as a self-inductance. That self-inductance we indicated as a L. L is equal to phi by I. EMF is equal to minus L di by dt. L is equal to minus E when di by dt is the 1 ampere per 1 second. It is a L is equal to minus E. What is the units? What is the units? What is the units? L is equal to phi by I. L is equal to phi by I. We know that flux units. What is the flux units? Webers. What is the current units? Amperes. Then what is the units? Weber per ampere. This Weber per ampere we will write as a Henry. Henry. This Henry is indicated by H. This Henry is indicated by H. This is the units. So, self-inductance is indicated by L. What are the units? Weber per ampere or Henry. Henry is indicated by H. Next, mutual inductance. Mutual inductance. Here, if the current is passing through the primary coil, changes then the EMF induced in the secondary coil. This phenomenon is called as a mutual inductance. So, we are giving supply to one coil. In that coil, we are getting current. Then the EMF is producing in the another coil. Then the EMF is producing in the another coil. That type of inductance we called as a mutual inductance. That type of inductance we called as a mutual inductance. Now I am taking two coils. The two coils having number of turns n. First coil, primary coil is connected with the battery. First coil is connected with the battery. This coil we considering as a primary coil. Which coil is connected to the supply? That coil we called as a primary coil. Another coil we called as a secondary coil. So which coil is connected to the battery or supply? That coil we indicate as a primary coil. Another coil is secondary coil. This secondary coil having also number of turns, but this secondary coil is connected with the galvanometer. This secondary coil is connected with the galvanometer. When we are giving to the supply, current will be passing through the coil. Current will be passing through the coil. Here also same, I am giving current is 3 amperes or 5 amperes something. But here current is gradually increasing according to the voltage. The coil is producing magnetic field. The coil is producing magnetic field. That magnetic field is passing through the secondary coil also. So here we are giving the supply to this coil. What is happening? In this coil, current is passing through the coil, magnetic field is producing. That magnetic field is passing through the another coil. Here, current is increasing gradually. Gradually it is increasing means flux also increasing gradually. Gradually flux is increasing means change in flux is happening. That change in flux is happening in the secondary coil also. So here what is happening in the secondary coil? EMF is inducing. For this primary coil we are giving the current, but in the secondary coil we are getting the EMF. This is the mutual inductance. Here we are giving current, but here we are getting EMF. Why? Here also we are getting the change in magnetic flux. Change in magnetic flux is there, we are getting EMF. This is we call as a mutual inductance. This is we call as a mutual inductance. So, current is giving to the primary, current is giving to the primary, flux is producing by the secondary. Flux is producing in the secondary. Then what is the relationship? Phi S is proportional to the primary current. Secondary coil flux is proportional to the primary current. Then phi S is equal to, I am taking constant value is M. This M we called as a mutual inductance. What is the equation? M is equal to phi S by IP. Phi S by IP. Secondary coil flux by primary current. Secondary coil flux by primary current. This is the mutual inductance. What is the EMF? We know that E is equal to minus d phi by dt. E is equal to minus d phi by dt. E is equal to minus d by dt. What is the phi value? MIP. M is the mutual inductance. IP is the primary current. Then E is equal to minus M is the constant minus M DIP by dt. DIP by dt. Then this is the EMF equation. From this equation, From this equation, what is the m? M is equal to minus E by di by dt. M is equal to minus E by di by dt. Here di by dt is the 1 ampere per 1 second we are considering. Then M is equal to minus E. M is equal to minus E. Here di by dt is equal to 1 ampere per second we are taking. Then mutual inductance is equal to minus EMF. This is the mutual inductance, guys. Hope you understand. Next one. Mutual inductance of two long coaxial solenoids. Two long coaxial solenoids. What is the shape of solenoid? Circular shape. Here we are taking two long coaxial solenoids. What is the mutual inductance of two long coaxial solenoids? We will find out the mutual inductance. Simple, guys. So, I am taking first one solenoid. What is the shape of solenoid? Circular shape. In this solenoid, I am taking another solenoid. So, I am considering this is the outer solenoid. I am considering as a S2. It is S2. It is S1. Outer solenoid I am considering as a S2. Inner I am considering as a S1. So for these two solenoids having common axis, for these two solenoids having common axis, that is called as a coaxial solenoids. So these two solenoids having common axis, that's why it is called as a coaxial solenoids. For this, I am considering S2 solenoid number of turns is N2. For S1, I am considering number of turns is N1. Current also, here I am considering I2, here I am considering I1. And number of turns per unit length, I am considering as a N2 here, here I am considering as a N1. Next, what about length? For both solenoids, we are considering as a L. Length, L, equal length we are taking. We know that phi is equal to BA cos theta and B is equal to mu naught Ni. We know that here solenoid is a which shape? Circular shape. Then area is equal to pi or square. Then N1 I am considering here. What is the equation, guys? I am considering N1 phi 1 is equal to N1 phi 1 is proportional to the current I2. Here proportional constant I am considering as a M. Here I am considering I2 here. Current giving to the secondary solenoid. So outermost solenoid I am giving the current. That is I2. Where flux is producing? In the inner solenoid. In the inner solenoid. For second, for the outer solenoid, we are giving the current. Where we are getting flux? In the inner solenoid. That's why it is a with respect to 1 to 2. With respect to 1 to 2. Here we are giving current to the outer part. But here we are flux we are getting in the inner solenoid. Then N1 phi 1 is proportional to the I2. Flux is proportional to the current. Here we are taking number of turns. That's why N1 phi 1. So current I2 we are giving, but we are getting the flux in inner. That's why it is a phi 1. For phi 1, inner solenoid having number of turns is N1. Number of turns is N1. Next, M1 to I2. M1 to I2. This is the first equation I am considering. I am considering it is a first equation. I am considering it is a first equation. Then we know that N1, phi 1, we know that N1, phi 1 is equal to N1, what is the phi? BA cos theta. What is the phi? BA cos theta. First equation, N1 phi 1 is equal to M12 I2. What is the second? N1 phi 1 is equal to N1 BA cos theta. Here I am considering theta is equal to 0. 0 degrees. Then what is the equation? N1 phi 1 is equal to N1 BA. What is the B value? What is the B value? Mu naught Ni. Mu naught Ni. What is the B value? Mu naught Ni. Mu naught Ni. Which current? I2 current we are giving. That's why here we are taking I2. And here we are giving B value. Where we are getting? Where we are getting here? In current is giving to the N2. So number of times we are taking in the outer part of the solenoid. That's why here we are considering N2. What is the area? Pi or square. Pi or square. What is the area? Pi or square. Here we are considering area of the solenoid. Area of the solenoid. Then N1 phi 1 is equal to, we know that N1 is equal to N1 into L. N1 into L. Then mu naught N2 I2 pi R1 square. This is the second equation. This is the second equation. This is the second equation. This is the first equation. Equate both the equations. Equate both the equations. M12 I2 is equal to, what is this equation? N1 N2 mu naught pi or 1 square L I2. L I2. Here in both I2 is there. Here in both I2 is there. Then M12 is equal to M12 is equal to N1 N2 mu naught pi R1 square L. Similarly, M21 is equal to, we are getting same thing. N1 N2 mu naught pi R1 square L. So finally we concluded M12 is equal to M21. So here both the mutual inductance are equal. This is equal to the capital M. What is the equation M? N1 N2 mu naught pi R1 square L. This is the mutual inductance for the two long coaxial solenoids. Next, expression for the magnetic energy stored in a solenoid in terms of magnetic field, area and length. We know that I am taking one coil. I am taking one coil, and then I am giving supply to this coil. I am giving supply to this coil. Here what is happening, guys? Some work done is occurring. Some work done is occurring. How? Every time EMF is opposing the here EMF is every time opposing the magnetic flux. Here every time we are getting opposing the EMF. That's why we are getting work done. Then we know that dW by dt is equal to velocity into current. So we know that dW by dt is equal to velocity into current. What is the dW by dt? Power. Power is equal to voltage into current. Then we know that dW by dt is equal to minus L di by dt into I. Then here dt cancel. We are getting dw minus li di. Then take integration on both sides. We are getting w is equal to, we know that integration of dw is equal to w. Then what is I into di? Half I square L. It means W is equal to minus half Li square. This is we consider as a energy. Half Li square. Work done is equal to half Li square. Substitute here L value and B value. Then we will get energy in terms of BAL. In terms of BAL. U is equal to half L I square. U is equal to half into what is the L? Mu naught N square AL. Mu naught N square AL. What is I? What is I? B by mu naught N. B by mu naught N. It is a I is a square. I is a square. Then U is equal to half mu naught N square AL. B square mu naught square N square. Here N square cancel. Mu naught, this square will be 1. Finally we are getting energy is equal to, U is equal to B square by mu naught AL. This is the energy in terms of magnetic field, area and length. So these are the topics in the electromagnetic induction, guys. Total syllabus over. Hope you understand all topics. And next Wednesday, our Satyan sir is taking live. Thank you one and all.